Suppose that we had a linear map T from a vector space V to a vector space W, and that we had two different bases, B and B prime for V, and two different bases, C and C prime for W. Well, then we can form two matrices for T. We could form the matrix of T with respect to the initial basis B and final basis C. And we could also form the matrix for T with respect to the initial basis B prime and the final basis C prime. So again, it's natural to ask, what is the relationship between those two things? They both express the same information, that is, they describe the linear map T, but they do it in different ways. So there should be some kind of connection between them. This connection is called the change of basis formula, and we're going to prove it in this video. So here's a statement of the change of basis formula. It's with precisely the same notation I used on the previous slide. We take a linear map T from V to W. We take two different bases, B and B prime for V, and we take two more bases, C and C prime for W. The change of basis formula then is this equality at the bottom here. It says that the matrix of T with respect to initial basis B prime and final basis C prime is equal to the product of three matrices. First, the matrix of the identity with respect to initial basis C and final basis C prime, then the matrix of T with respect to initial basis B and final basis C, and then the matrix of the identity with respect to the initial basis B prime and the final basis B. So that really does do what we wanted. It connects the two different matrices for T. In order to prove it, we need to use the theorem from the last lecture, which was about the matrix of a composition of two linear maps. I've copied that theorem at the bottom there so that you can see it, and I'm going to refer to it when we do this proof, because the proof is simply two applications of this theorem on composition. So let's start a proof of the change of basis formula. We start by thinking about a composition of linear maps. And what we will have is, first of all, the identity map from V to V. Next, T from V to W. We'll choose bases for those vector spaces. So I choose the basis B prime for this V, and B for the next V, and C prime for W. We're now going to apply the theorem from the last lecture. That tells me about the basis of the composition, that tells me about the matrix of the composition of those two linear maps. Specifically, that T composed with the identity on V, the matrix of this with respect to initial basis B prime and final basis C prime will be equal to the matrix of T with respect to initial basis B and final basis C prime multiplied by the matrix of the identity on V with respect to initial basis B prime and final basis B. So this is an application of the theorem which we had in our last lecture. But of course, what you've got on the left is the matrix of T composed with the identity. But when you compose T with the identity, you just get T again. So really, what we have here is the matrix of T with respect to initial basis B prime and final basis C prime. So this looks quite similar to the change of basis formula. The thing on the left-hand side is the same as what's on the left of the change of basis formula. The thing on the far right, the matrix of the identity of V with respect to initial basis B prime and final basis B, that's also part of the change of basis formula. But there's still a difference. So we need to get rid of this matrix of T with respect to initial basis B and C prime. We're going to substitute that for something else in order to get the change of basis formula. So what I'm going to do now is just give a name to this equality which we've written here, because I'm going to do a substitution into it later. So we'll refer to this as equation 1. So our problem was the matrix of T with respect to initial basis B and final basis C prime. I need to substitute with something else in order to get the change of basis formula. So we're now going to consider another composition. This time we will think about a composition of linear maps going from V to W and then to W again. The first linear map will be T, and the second linear map will be the identity map on W. And again we're going to choose some bases. So this time we will take the basis B for V, C for W, and C prime for the second W. Again, we're simply going to apply the theorem about matrices of compositions, and what it will tell us is the matrix of the identity on W composed with T with respect to the initial basis B and final basis C prime is equal to the matrix for the identity on W with respect to the initial basis C and final basis C prime multiplied by the matrix of T with respect to the initial basis B and the final basis C. Once more, on the left-hand side of that equation is the matrix of the composition of the identity with T. When you compose the identity with T, you just get T again. So again, we can simply write what's on the left as the matrix of T with respect to initial basis B and final basis C prime. I'm going to call this equation number 2. We can now substitute equation 2 into equation 1, because if you look on the right hand side of equation 1, you've got the matrix of T with respect to initial basis B and final basis C prime. Equation 2 tells you that the matrix of T with respect to initial basis B and final basis C prime is equal to something else. So we're going to use that to substitute 2 into 1. When I do this, on the left of 1, I've got the matrix of T with respect to initial basis B prime and final basis C prime. I'm substituting for the thing that comes next in equation 1. So I'll substitute the right-hand side of equation 2. I have the identity on W, that matrix of that with respect to initial basis C, final basis C prime. And then I have the matrix of T with respect to initial basis B and final basis C. And then I've got the last part of equation 1, which is the identity, matrix of the identity on V with respect to initial basis B prime and final basis B. That is the change of basis formula, so we are finished.